Lesson 2. Polygons. The polygon is a closed shape formed from 3 sides or more. So, the lowest number of the sides or line segments is 3. Now, when we look at the figure 1, we have a triangle. And we notice that the triangle has only 3 sides. And in the second figure, we have 4 sides. So, it's called quadrilateral. So, we have 3 sides called triangle and 4 sides called quadrilateral. And in the third figure, we have 4 sides, so we have a quadrilateral. And if we look at the fourth figure, we have 5 sides, so it's called pentagon. And in the fifth figure, we have 6 sides, so we have hexagon. It's called hexagon. And if we have 7 sides, it will be heptagon. And if we look at the figure 6, we have 8 sides. And it's called octagon. Now let's complete the table. In the figure number 1, we notice that a triangle, so the number of sides is 3 and number of vertices 1, 2, 3, and the number of angles is 1, 2, 3, so we have 3 and 3 and 3. In the second figure, we have quadrilateral, so we have to say the number of sides is equal 4, number of vertices is also equal 4, and the number of angles equal 4. In the figure number 3, we have 4 sides and 4 vertices and 4 angles. In the figure number 4, we have 5 sides and 5 vertices and 5 angles. In the figure number 5, we have 6 sides and 6 vertices and 6 angles. In the figure number 6, we have 8 sides and 8 vertices and 8 angles. And I think that you note that in any polygon, the number of sides equal the number of vertices equal the number of angles. So, what do you note? I note that the relation between the number of sides of a polygon with respect to the number of its vertices and the number of its angles. Now, let's complete this. For any polygon, number of sides equal number of vertices equal number of angles. Trial 1. Complete drawing the square ABCD, then answer the following. Consider the unit of length is 1 centimeter. Now let's complete this. We have to draw the line segment AD and the line segment CD. So we have to draw it AD and CD. In letter A, we have AB equal BC. Why? Because AB is 1, 2, 3, 4 centimeters and BC is equal 1, 2, 3, 4 centimeters. And also equal CD 1, 2, 3, 4. So CD is equal 4 centimeters and AD equal 1, 2, 3, 4. So equal 4 centimeters. And in letter B, we have the measure of the angle. B equal the measure of the angle. We have to find the measure of angle B. So using the protractor, we have to find the measure of angle B. Now we have to use our protractor and we notice that B equal 90 degree. And the measure of angle C is equal 90. And the measure of angle D is also equal 90 degree. And A is also equal. 90 degree. To find the measure, you have to use your protractor. Then, the measure of angle B is equal measure of angle C is equal measure of angle D is equal measure of angle A. So, all of them equal 90 degree. Letter C, from all above, it can be said that the square is a pentagon or quadrilateral or hexagon. The square have 4 sides, so it's called quadrilateral. Quadrilateral. That has 4 sides that are equal in length and 4 angles that are equal in measure, and the measure of each is 90 degree. And try to check by drawing other squares on graph paper. And I have a question. What's about the AC and BD? It's called diagonals. So what's about the diagonals? I have to use my ruler to measure this length. I note that AC equal BD. Letter D. Using your geometric instruments, check that AC is equal BD. And for other squares that you draw on graph paper, you will find that the diagonals of the square are always equal in length. Note, in any quadrilateral, the diagonals is the line segment joining 2 non-consecutive vertices. From the above, we deduce that the diagonals of square are equal in length. And letter E, using the set square or the protractor, check that AC is perpendicular to BD, and similarly for other squares that you draw on graph paper. From the above, we deduce that the diagonals of each square are perpendicular. And letter F, FM is the point of intersection of AC and BD. They use the geometric instruments to check that MA equal MB equal MC equal MD. And similarly for other squares that you draw in graph paper. So we deduce that the diagonals of the square bisect each other. So we deduce that the diagonals of the square are equal in length and that the diagonals of the square are perpendicular and that the diagonals of the square bisect each other. Trial 2. Complete drawing the rectangle ABCD, then answer the following. Consider the unit of length as 1 centimeter. We have to draw AD and CD now is equal. AB equal 2 centimeters and also CD is equal 2 centimeters. So AB equal CD equal 2 centimeters. And BC equal 4 centimeters and also AD is equal 4 centimeters. So BC is equal AD. So we deduce that in the rectangle, every 2 opposite sides are equal in length. And letter B, the measure of angle B is equal the measure of angle. Okay, we have to use our protractor to know the measure of B. The measure of B is equal 90 degree, and also the measure of angle C is equal 90 degree, and the measure of angle D is equal 90 degree, and the measure of angle A is equal 90 degree. So the measure of angle B is equal the measure of angle C is equal the measure of angle D is equal the measure of angle A is equal 90 degree. So we deduce that in a rectangle, all angles are equal in measure and the measure of each is 90 degree. Letter C. From all the above, it can be said that the rectangle is a quadrilateral that has 4 sides, and every 2 opposite sides are equal in length, and 4 angles that are equal in measure, and the measure of each is 90 degrees. And you can check by drawing other rectangles on graph paper. Letter D, use the geometric instruments to identify the relation between AC and BD. And similarly for each rectangles that you draw on graph paper. So we deduce that in the rectangle, the diagonals are equal in length. Letter E, using the set square or the protractor, check that AC and BD are not perpendicular. And similarly for other rectangles, not squares, that you draw on graph paper. So the diagonals of the rectangle are not perpendicular. Letter F, if N is the point of intersection of AC and BD, use the geometric instruments to check that NA equal NC and NB equal ND. And similarly for other rectangles that you draw on graph paper. So we deduce that the diagonals of the rectangle bisect each other. Now focus on this. In the first figure we have rectangle, so in the rectangle we have each 2 opposite sides are equal in length. Each 2 opposite sides are equal in length. And the angles are equal in measure, each of them equal 90 degrees. And if we talk about the diagonals of the rectangle, they are not perpendicular, but they are bisect each other, and they are equal in length. And the second figure we have square. In the square we have 4 sides are equal in length, and 4 angles equal in measure, and each of them equal 90 degrees. And if we talk about the diagonals, so the 2 diagonals are equal in length and bisect each other, and they are perpendicular. And if we look at the third figure, we have triangle, and in triangle we have no diagonals. We have 0 diagonals. Why? Because the diagonal is the line segment joining 2 non-consecutive vertices. And when we look at the triangle, all vertices are consecutive, so there is no diagonals. And we notice that the triangle have only 3 sides or 3 line segments. In the fourth figure we have trapezium. Okay, so in the fourth figure we have trapezium, and in trapezium we have only 2 opposite sides are parallel and not equal. And when we talk about rectangle, each 2 opposite sides are equal and parallel, and in the square are equal and parallel. So in trapezium we have only 2. We have only 2 opposite sides are parallel and not equal in length. In the fifth we have rhombus. The rhombus have all sides are equal in length, all sides equal in length, and the 2 diagonals is not equal in length, but they are perpendicular and bisect each other. And each 2 opposite sides are parallel. Each 2 opposite sides are parallel, and all sides are equal in length. And in parallelogram we have each 2 opposite sides are equal in length and parallel. Each 2 opposite sides are parallel and equal in length. And if we talk about the diagonals, we have the 2 diagonals bisect each other but not equal. but not equal in length. And if we talk about angles, each two consecutive angles equal 180. Each two consecutive angles equal 180. So when we look at the rhombus, we can say the rhombus is a parallelogram. Rhombus is parallelogram, but all sides are equal. And if we talk about the rectangle is also parallelogram, but each angle is equal 90 degree. But each angle equal 90 degree. And if we talk about the parallelogram and square, we can say the square is a parallelogram, but each angle equal 90 and all sides are equal in length. So we have rectangle, each two opposite sides are parallel and equal in length, and each angle equal 90 degree. And if we talk about the square is a quadrilateral, and each two opposite sides are parallel and all sides equal in length and all angles equal in measure, each of them equal 90 degree. And in the trapezium we have only just two opposite sides parallel and not equal in length. And in the rhombus, each two opposite sides are parallel and all sides are equal in length. In the parallelogram, each two opposite sides are equal and parallel. And in the parallelogram and rhombus and square and rectangle, the sum of each two consecutive angle is equal 180. And when we talk about the triangle, the sum of the interior angles in triangle is equal 180. Join each figure to the suitable name. The first figure have only two opposite sides, parallel and not equal in length, so it's called trapezium. The second figure, we have two opposite sides, each two opposite sides equal and parallel, and the all angles is equal and each of them equal 90 degree, so this is a rectangle. And the third, we have each two opposite sides equal and parallel, but the angles is not equal 90, so it's called parallelogram. And the fourth, we have each two opposite sides are parallel and all sides are equal in length. And if we talk about the diagonals, they are perpendicular, so this called rhombus. And in the fourth, we have each two opposite sides are parallel and all sides equal in length and all angles equal in measure, so that's a square. Now put true for the correct statement and false for the incorrect one, and correct the wrong statement. Okay, the angles in letter A, the angles of a rectangle are right. This is true. Letter B, the sides of a square are equal in length. This is true. Letter C, the opposite sides of a parallelogram are parallel. This is true. Letter D, the measure of any angle of the square is equal 45. No, of course not. We had studied that equal 90 degrees, so this is wrong and it will be 90 degree. Letter E, any of the four angles formed from the intersection of two straight lines is a right angle. No, this is false, because they should be perpendicular. So any of the four angles formed from the perpendicular of two straight lines is a right angle. And letter F, any angle of four angles formed from the intersection of two perpendicular and straight lines is a right angle. Yes, this is true. Letter G. Two parallel straight lines are two non-intersection straight lines. Yes, they will be never intersect.